Hello, welcome to another Leetcode video. So this is another in a series of Meta and Facebook tagged videos. This is binary tree vertical order traversal. So the question reads that we are given the root of a binary tree. We want to return the vertical order traversal of its nodes values. So from top to bottom, column by column. And if two nodes are in the same column, the order should be from left to right. So we can kind of see here, just from this example, get a pretty general idea of what they're looking for. So we see the output first is just this array of 9. And we see that this column here just contains 9, which is why we output this first, because this is our leftmost column. And from top to bottom, the only node is 9. Next, we have 3 and 15. So again, here, this is our next column from left to right order, and we see that the nodes are in order from top to bottom, so we have 3 and 15. Likewise, we have 20, this is the only node in this column, and then 7. So pretty straightforward. So let's hop into the example and see exactly how we can solve this. So to solve this problem, we're going to use breadth first search. We could also use depth first search here, but I think breadth first search is a little more simple and makes a bit more sense for this question. So for breadth first search, we're always going to start with a queue. And what would our queue start with in this case? So what we want to do is start our queue with a tuple or an array of 2 elements, where the first element is going to be the root node that we're given. And then what we're going to do is put 0 here. So what does the 0 represent? So this means that we are at column 0, and column 0 is going to be this middle column right here where our root node is. So how do we actually use this? Well, we could pop this off the queue, look at this, and say we're looking at 3, 0 right now. So we're at the node 3, this is column 0. So if we can go to the left, what does this mean for our column? So if we're at column 0 and we go left, we could subtract -1 from here, right, to get column -1. Likewise, we can go +1 on this side for column, not column 2, for column 1, right? So then what do we do, say, at 20? So again, we can go -1. So we're back at column 0 here, because you see we were at column 1, but we subtracted 1 and we're back at 0. Likewise here, we go +1 and we're at 2. So essentially what we're going to do is, as we're processing the nodes, we can look at this current column value, and from there we can traverse the tree. So what would we do with 3 and 0? So we'd say, okay, we have 3 and 0. At column 0, we see a 3. So in our hash map here, let's just add a 3 for column 0. Then what we're going to do is say, if this has a left child, it does. Let's add it to the queue. So we can do 9, and then we're going to have -1. And remember that we have -1 because we're at column 0 and we're subtracting 1. So our new column here is -1. Likewise, what we could do for the right child is say, is there a right child? There is. So we can do 20, and then we're going to add 1 to our current column. So now we have 1 here. So we're going to get rid of this and move on to our next node. So now our next node is going to be 9 with a column of -1. So we see 9. We haven't seen any elements for -1 yet. So we say -1. We can just add that in here. So now for -1, we have 9. So no left or right child, so we don't do anything here. Erase this. And now we're going to move on to 20. So now we're at 20. We haven't seen anything for 1 yet, so we're going to add 20 into column 1. Then we're going to check its children. So we're going to see, does 20 have a left child? It does, so we can add that child. And then we're going to do the current column, which is 1, -1, which is 0. So let me cross this off. And then we're going to do our right child. And it does have a right child, so we're going to do 17 plus 1 to our current column, which is 2. Okay, so now we just have 2 more nodes to process. So let's get rid of this. Then we can process this node. We have 15 and we have 0. So we see column 0. Let's add this on to what we've seen for column 0. Now look at what we have for column 0. this is all the nodes for column 0, but you'll see it's also in sorted order top to bottom. So just by going through depth first search, we kind of guarantee that we're going to see nodes that are at a higher level before we hit nodes at a lower level, even then they're in the same column. That's why we do breadth first search, just to kind of guarantee that. So no left to right child, we continue, and then we finally process our final node, 17, 2. So now we have this. We haven't seen anything for column 2, so we can add 17. And then no left to right child, so we're just done. So if you remember our answer, this is essentially all the array elements that we had. But now what we want to do is we want to have these in order, right? So we had -1, 0, 1, 2 is the ordering that we want. But you see that these keys aren't in order. We can't depend on any kind of ordering for a hash map keys. So what we could do is we could get these keys, we could sort them, but that would be an O of n log n solution because we have to then sort this collection. However, we can do this in a bit of a smarter way. So if as we're going through these keys, we keep track of both the min and the max, so we had -1 and 2, we know that in this range are all the elements we're concerned with. So we can just iterate through this range to get our elements here in order. So let's see what that looks like. So we'll start with -1. See what's at -1. Okay, so we have 9. Then we'll go to 0, because that's next in our order. We'll have 3 and 15. Then we'll have 1, which is 20. And then we'll have finally 2, which is 17. So this is the exact ordering we're looking for, and this would be our answer. So essentially what we're doing is we're using breadth first search to go through all the nodes and represent them as columns in a hash map here. And then if we know the range of the columns that we have, we can just iterate through these numbers and get our list in order. So we can do this in O of n time. So hopefully this made sense. Let's hop over to the code and see exactly how we're going to make this work. So the first thing we do here is handle this edge case where we're not given any root. Here we're just going to return an empty list. So then we make this hash map called columns. And what this is going to do is the key is going to be the column, so 0, -1, 1, etc. And it's going to point to a list of all the elements in that column. And this list will end up being sorted in top to bottom order. Then we're going to start our queue. It's going to just start with the root node as well as 0, the column indicator. We're also going to have 2 variables, and this is going to represent the minimum column that we've seen and also the maximum column that we've seen. And we're going to use this at the end in order to iterate through all our keys in O of n time. So while we have elements in our queue, we're going to pop off that node and column value for the next node we're looking at. And we're just going to add that value into our hash map for that column and update our min and max column values. So all pretty standard. Then what we're going to do is we're going to look and see if there's a left child. We're going to add it onto the queue. So we're going to say onto our queue add node left, but also take the current column, the column that we got from our current node, and subtract 1. And this means that we know that this column is going to be 1 less than the current column we're looking at. Likewise for the right, we do the same thing. If there is a right node, we will add that right node onto the queue along with the current column plus 1 to indicate that it's 1 column to the right of where we are right now. Then at the end, we're just going to do this little list comprehension. But what this is doing really is just going through the range from min to max. And then for each I in there, we're taking that list from the columns that we stored. So let's submit this and make sure it works. And it does. So this is another question from the Facebook and meta tag questions. If this was helpful, more are coming, and thank you for watching.